We'll take a look here at doing these hypothesis tests, but this time for proportion problems. So this time with your null and your alternative hypothesis, instead of starting with mu, you're going to start with p, right? Not p hat, but p, because we're starting with a parameter, something that talks about, um, right? A that would be the population or the true value, or we would call that the parameter. Remember, before when we did these things, we used p hat, and that was for a sample, right? And that's what's called a statistic. Statistic. All right, so there you're going to use p. Remember, for the null, it's always going to have some kind of equality, so it's equals, greater than or equal to, less than or equal to, and so p not equal to, greater than, or less than. And then there's going to be some number that goes here, and it's going to be the same number, both the alternative and the null. All right, so your test statistic this time, all right, so we have a z. Remember, z always went with proportions, and it's the same idea as before. It's statistic minus parameter over standard deviation. So that's going to be p hat minus p, right, observed minus predicted over the standard deviation. And remember, the standard deviation for a 1 proportion, and if you look on your sheet, you'll see it, it's going to be pq over n. Now, here's one thing that's different than we did with intervals. Because remember, with intervals, we pretty much use p hat the whole time. So when you're doing a confidence interval, you always use p hat because, well, in theory, we use the interval to figure out what is the true value. The difference with a test, right? Right. So you think about an interval, um, you're trying to find p. With a test, right, which is when you always use just regular p for a test, there's going to be some kind of, there's a claimed p. Somebody says, hey, I think I know what p is, so this is it. So we're going to test to see if that's true or not. An interval, we're trying to see where is the p. A test, we're testing to see if the one that someone claims is legit or not. So the conditions here, a lot of them are going to look very, very similar to the ones we did with intervals. The first one's always going to be random. And then the next one, we did NP and NQ. We did NP hat and Q hat before. Now we're doing NP and Q. We want to make sure those are greater than 10. And then we want to make sure the population is greater than 10 times n. So those three conditions are the same thing, except we're using p's the whole time. With tests, we're using p the whole time. Just a quick reminder, right? If the p-value is greater than alpha, you're going to fail to reject. And then if your p-value is below your cutoff value, you will reject the null. Right? And again, if you're not given an alpha, just use 0.05. And then finally, you're going to interpret your results. Just go back. It appears, evidence suggests, so on and so forth, right? Make sure that you put that kind of grayish language right there, because we're never actually making a true hard and fast claim. So here's an example. In the book, Life in America's Small City, this author reports in 1990, 22.1% of 16 to 19-year-olds were high school dropouts. 95, a random sample of 193, showed that 32 were dropouts. Does this indicate the proportion was less? So this is what is a one proportion z-test. All right, so instead of a one proportion z-interval, it's a one proportion z-test. All right, so HO, HA. So this 22.1%, that's the claimed value. So somebody claims that it is 0.221. We're looking, is it now less than 0.221? So here's a one-tailed test. So first off, random is given. All right. We need more than our sample size, a random sample of 193. So we need more than 1930 people in Key West. last thing we need to make sure, 193 times our P, 0.221, and so 0.779. Those are both going to be greater than 10. All right, so to this point, we can kind of let the calculator take over for us. So if we go into stat, we're going to do a one prop z test. So over here on the side, I'll just kind of walk through what you'll see on the calculator. So our P0, well, that's the claim proportion, 0.221. Our X, it was 32 out of a total of 193. And then it'll say prop, and we're doing less than the null, and then calculate this thing. So here's the beauty of running that test. Now we just go back and fill in all the mechanics of it. So I know my z-score is negative 1.84. The p-value here is 0.03. So they don't give me, oh yeah, they do. They say use alpha as 0.05, so 0.03 less than 0.05. So we will reject the null. Now let me go back and fill the z formula. And remember, we do observed. So the observed p hat, 0.166 minus the claim of 0.221 over, and we're using p the whole time now. So 0.221 times 0.779 over n, which was 193. Put the whole thing under the square root. I'm not actually going to do any of that work. It's already been done for me. We've kind of gone through all this stuff. We're rejecting the null, so evidence suggests that the proportion is below 0.221. So, indicating the dropout rate has well, lack of better terms, dropped significantly. So there's what a one prop z test will look like.